In recent decades, astronomers have focused their attention on a mysterious planet located at the edge of our solar system, known as Planet 9. This hypothetical planet is believed to be a super-Earth, with a mass at least 6 times that of our planet, and it would be located at an enormous distance from the Sun, far beyond Neptune's orbit. Its existence, while not yet confirmed, has been proposed to explain certain anomalies in the orbits of distant objects beyond Neptune. But why should such a remote planet exist? And if it truly does, why have we not yet been able to detect it? The search for objects in the outer solar system has deep roots, dating back to the discovery of Neptune in 1846. The planet was identified through an analysis of anomalies in Uranus's orbit, which seemed to defy Newton's laws of gravity. Astronomers realized that something was influencing Uranus's orbit, and it was hypothesized that another planet's gravitational pull was responsible for these distortions. Over time, the search for a celestial body beyond Neptune became a central issue in astronomy, but it was not until 1930 that, during the quest for this mysterious planet, Clyde Tombaugh discovered what would be identified as Pluto. Although this discovery was initially seen as a solution to the problem, it was later understood that Pluto, unfortunately, was not massive enough to explain the anomalies in Uranus's orbit. Orbital anomalies persisted for many decades. Only in 1989, thanks to data collected by the Voyager 2 probe, was it possible to obtain crucial information to better understand Neptune's mass. It was discovered that Neptune's mass had been underestimated by about 0.5%, and this correction was enough to explain the anomalies in Uranus's orbit. However, the fascination with a possible unknown planet at the edge of the solar system continued to intrigue astronomers, fueling the search for yet undiscovered celestial bodies. In 1992, astronomers David Jewett and Jane Liu discovered Albion, a body located beyond Neptune's orbit. This discovery marked the beginning of an era in which numerous trans-Neptunian objects were identified, including dwarf planets such as Pluto, Haumea, Makemake, and Eris. Despite these discoveries, an even more remote and mysterious region called the scattered disk captured scientists' attention. This region is populated by objects with extremely eccentric orbits and peculiar inclinations. A notable example is Sedna, whose aphelion, the farthest part of its orbit from the Sun, reaches 937 astronomical units, about 30 times the distance between Earth and the Sun. Its orbit is so elongated that it takes approximately 11,400 years to complete one full revolution around the Sun. Other bodies similar to Sedna have been discovered over the years, fueling the suspicion that an unknown but much more massive object could be responsible for the gravitational influence guiding the orbits of these distant objects. Further evidence emerged in 2012 when astronomers Scott Shepard and Chad Trujillo identified another distant object, named 2012 VP-113, far beyond Neptune's orbit. The discovery of similar bodies led to speculation that a stronger gravitational force, coming from a massive object, might be responsible for an unexplained alignment among these orbits. In 2016, 2 Caltech astronomers, Mike Brown and Konstantin Batygin, hypothesized that a very distant planet, which they called Planet 9, could explain the unusual distribution of these extreme trans-Neptunian objects' orbits. According to their theory, Planet 9 would have a mass about 6 times that of Earth, and would orbit at a distance ranging between 300 and 500 astronomical units from the Sun, so far away that detecting it would be incredibly difficult. The planet would be located at the outer edges of our solar system, and its orbit would be extremely inclined compared to the other planets. The possibility that Planet 9 exists is now taken very seriously by the scientific community, although so far all attempts to observe it directly have been unsuccessful. Nonetheless, several studies have suggested that the gravitational anomalies observed in the orbits of scattered disk objects could be explained by a massive body exerting significant gravitational influence. The difficulty in locating Planet 9 is related to its distant position and possible faint brightness, making it invisible to traditional telescopes. Moreover, its orbit could be so far away that even a small error in estimating its position could prevent its detection. If Planet 9 exists, its discovery would be one of the most important in astronomy, as it could provide new insights into the formation and evolution of our solar system. It could also be the key to understanding how the planets of the outer solar system have evolved over billions of years, giving scientists a clearer view of the processes governing the birth of planetary systems in general. Until we can directly observe this mysterious planet, however, its existence will remain one of the great unknowns of modern science. Thank you for watching. Leave a like and subscribe to the channel so you don't miss upcoming videos.